Okay, so we're solving linear equations. Equations was, I don't know what I was trying to say. Okay, what's different today? There's equal signs. We have equations, not expressions. Okay? With expressions, did we ever do opposite? No, because everything was already together. Now that we have an equal sign, we have two sides, right? The only time you do opposite is if you're moving it to the opposite side, yes? Sarah, you can grab a packet right there in that black thing on the wall. Sorry, didn't even think about it. Look on the wall, the black thing hanging behind Joe. There you go. It's going to look just like this. It's day 3 through 4. Okay, so we have addition property of equality. Okay, it's going to make more sense with numbers, but I got to teach you the letters. It's just saying if A equals B, which also addition, I want you to realize is very, very, very similar to subtraction. Can I write subtraction as addition? Yeah, plus and negative is the same thing as subtraction, addition. I don't know what I'm saying. Okay? If A equals B, that's like saying 4 equals 4. If A is 4, B is 4, yes? If I add another number to A to keep both sides equal, I have to do the exact same thing on the other side of the equal sign, yes? That's what keeps it equal. So here, if I have x minus 4 equals 7, they're exactly the same, but I'm trying to solve for x. What would I add to this side to get x by itself? 4, because I want to get rid of that minus 4 so I can add 4. And as long as I do the exact same thing to the other side, they'll still be equal. So I get x equals 11. Subtraction works the same way. Okay? So then we have multiplication, which is the same as division. Did you know that multiplying by 1/5 is the same as dividing by 5? Multiplying by 1/2 is the same thing as dividing by 2. Okay, multiplication and division are the same, or can be written the same. Okay, so if I have A equals B, say A is 4, so 4 equals 4. It's the same thing. If I want to multiply A times C, then I have to multiply B times C to keep it equal, yes? So looking at my example, how do I get rid of 3/5? Does anybody remember? We're going to multiply by the reciprocal. Good job. By the flip. Okay, I saw all that. Okay, so what is the flip? 5 over 3. What I do to one side, I have to do to the other. Okay, well, the top is more your multiplication. The bottom is your division. Multiplying by 5 cancels dividing by 5. Multiplying by 3 cancels dividing by 3, so we're left with A equals, now you can do this in your head, or you can use your handy-dandy calculator. 12 times 5 over 3 gives you 20. Any questions with the rules? Okay, and then we can throw a bunch of those rules together and all the things that we've learned together when we're solving. Okay, I know today's going to seem like a lot, but bear with me, yes? Okay, tomorrow there's no notes. Yay. Okay, before you solve, you have to make sure both sides are simplified. So I'm solving for y. That's my only letter. So that's what I'm trying to get by itself. Is y minus 1.2 as simple as it gets? Is negative 3.2 minus 6.6 as simple as it gets? No, they're like terms. Can I combine them? Yeah, so negative 3.2 minus 6.6 gives me negative 9.8. Bring down this side. So I'm still trying to get my y alone. What am I going to do now? Yeah, add 1.2 to both sides. What I do to one side, I have to do the other. That's what keeps it equal. And I can do plus 1.2, and it gives me negative 8.6. Any questions? I've done this before, yes? Cool. Okay, so look at the second one, another simple one. Single step this time. We're solving for x, that's my only letter. What's happening right there? Addition, subtraction, multiplication, or division? Multiplication. How do we cancel multiplication? Divide. So we're going to divide both sides by what? -4, by whatever's next to your variable you're trying to get alone. So I can cancel my -4's over here. And 16 divide -4 gives me what? -4. Now, did you know you can check your work on every single one of these problems by plugging it in? You only have one variable. So we had -4 times x. Well, what's x? -4. If I did it right, what should it equal? Did it work? Yes, so you can always check your work in your calculator, okay? What about this one? Say that again. We're going to have to move the x. Hello. Thank you. Jaden. Okay, but what makes this problem ugly? The fractions. What do we notice about all the fractions? They all have the same denominator. Are there any terms without a denominator? Or does every single term have a denominator of 7? When every single one has a denominator that matches, guess what you can do? Cancel it. Why? It's because it's an equation. You cannot do this with expressions. But what's the opposite of divide by 7? Multiply by 7. So if I multiply both sides by 7, multiplication cancels division. Multiplication cancels division. So when your denominators match all the way across, cancel them. Yeah? Okay, so that leaves me with 3x equals 5 plus 2x. Does that look way better? Yeah. Now, what do we want to move to solve this? The 2x. How do I move a plus 2x? Minus 2x. This zeroes out, and I'm left with x equals 5. 3 minus 2 is 1x, right? Is 1x the same thing as just x? Yes. Any questions? Pretty simple, yes? Okay, so look at D and E. These should be simpler ones as well. D looks like a mess, but it's really just because it's all separated. What did I say was your first step? To make sure both sides are simplified by combining like terms. What can I combine on that side of the equal sign? 6x minus 5x. What does that give me? 1x. Bring down my plus 8 equals, can I combine this side? Look at it. Yes. What's 8 minus 3? 5. Now what? Now does it look way simpler? Yeah, what do we do? Minus 8 on both sides. And I get x equals -3. Now, do I have to put that 1 with it? No. Okay, I want y'all to do E. Give y'all a second to try it. You try it? Okay, what do we get? 9. So here's the work. What did you do first? added 1 to both sides, and then divided by 3 and you were done. Yes? Super simple? Cool. What's ugly about this one? They're fractions. We have to distribute. Now, do the denominators match? Can we cancel them? No, but hear me out. When you have a single fraction, see how this is one fraction with one fraction bar equals one fraction with one fraction bar. You can cross multiply to solve. Do y'all remember doing that? I'm sure y'all have done it before, just with way smaller things. But you can literally just cross multiply. It saves you from creating a common denominator and then canceling that denominator. You get the exact same thing without having to do all the hassle. So remember, order doesn't matter when you multiply. So what's 5 times 2? 10, and I'm not going to multiply the x minus 6 yet, but I will. And then I'm going to multiply this one. What's 3 times 4? 12. And I get x plus 2. Now does it look way better? We don't have fractions anymore, and we can simplify. Yes? Cool. What do I do? Distribute. So we have 10 times x. It's 10x. 10 times negative 6. It's negative 60 equals 12 times x. It's 12x. 12 times 20. 12 times 2 is 24. Words are hard. Okay, when I have an x on both sides, I always like to move my smallest x first. It keeps me from dealing with negatives, and it's really, really important when we get to inequalities, because what happens when you divide an inequality by a negative? You know, with the symbols, you remember you have to flip it, so it kind of saves you from that. So if you create a habit out of it, it makes life easier. So I always like to move my smallest variable. That zeroes out. And I get negative 60 equals 2x plus 24. Now what? Minus 24. I'm running out of space. So I get 2x equals negative 84. Divide both sides by 2. And I get x equals negative 42. There are other ways to do this problem. I just feel like this is the easiest way, most efficient. We're popular this period. Thank you. Okay, so let's look at the back. I know, so exciting. Okay, a couple of these are important to talk about just because of small things. Okay, so if you look at G, what do we need to do? Distribute. Okay, so I get 5 times 3, 5 times Z, negative 8Z, which if it makes more sense to you to put a 1, negative 1 times 8Z, and negative 1 times 9, then do it. Gives you this. Am I done? What do I do now? Okay, so I have these that are alike, and what does that give me? Negative 3Z, and then I have 15 minus 9, which gives me 6. Now what? What do you think we do next? Add 3Z. Because we have a Z on both sides, we can't really always move the smallest one. So we get 6 equals negative 1Z. Am I done? No, why? What's keeping me from being done? The negative. Is the 1 keeping me from being done? No, because 1z and z are the same thing. It's the negative that I can't have. So how do I get rid of that negative? Huh? Yeah. But the mathematic reason is because if you divide both sides by -1, this cancels. 6 divided by -1 is -6. I want you to realize when you're just getting rid of a negative, if you make everything opposite, you'll have the same thing as if you divided everything by -1. Okay? Okay, I'm going to do one more all the way through, and then we're going to talk about one, and then we're going to do the special cases, and we'll be done. Yes? Almost done. I'm going to skip this one. It's super simple, just like some of the ones we've already done. Okay? So look at I. What do we have? A fraction. What do we do with our last set of fractions? Okay, can I cross multiply here? You actually can. Can we put this all over 1? Now is it a single fraction equals a single fraction? Yeah. So we get 3 times 6a plus 2 equals, well, what's 1 times 2? Yeah. Now what? Distribute. What's 3 times 6? So we have 18a. 3 times 2 is 6 equals 2 times a is 2a. 2 times 3 is 6. Now, what do I like to do first? Move my smallest variable. Which one's smaller, 18 or 2? 2, so I'm going to do minus 2a, and I get 16a plus 6 equals 6. Now, what do I need to move? Plus, how do I move it? Yes. What happens on both sides? It zeroes out. Is 0 a number? Yes, 0 is a number. It's okay to have 0. Okay, did my variable cancel? No, I still have my letter, so I'm not done. So I divide both sides by 16. And what's 0 divided by 16? 0. So there's your answer. Now, I had a lot of people earlier trying to tell me it was no solution. Why do you think they were trying to tell me that? Because of the 0. But I still had a. So you'll see in a minute, we'll look at a no solution problem. Your variables cancel when there's no solution. Our variable didn't cancel, and that's why we knew there was still a solution. Does that make sense? Okay. So I'm not going to do h. It just gives you a fraction. Y'all, it's okay to get a fraction as your answer. Yeah? But it's a simple problem. Let's save some time. I'm just going to start this one. What makes this problem ugly? The decimals. What do you notice about all the decimals? What place value are they? Not hundredth. Okay, this is the secret. Okay, so tenths place, 10 has how many zeros? 1, 10, 1, 0, right? 1, 0. Okay, that means a tenths place would be something like 0.2 because there's only one decimal number. How many do we have? 2. How many zeros does 100 have? 2. That's why it's the hundredth place. So what if I had 3 numbers after my decimal? It'd be the thousandths place because there's 3 zeros and 1,000, so on and so forth. Does that make sense? Cool. Okay, because every term, there's 3 terms, 1, 2, 3, okay, has a decimal, we can multiply this whole thing by 100. And what does that do to my decimal? Do y'all remember that rule? Moving the decimals when you multiply? Yes, so you can move them all twice to the right, and this becomes 25x. plus 1, 2, this becomes 10x minus 3 equals, move it twice, this becomes 5 times 22. Now does it look prettier? Does that stress you out a little less? So if you can get rid of the stuff that stresses you out, get rid of it. Fractions and decimals. Okay? Any questions with that? Okay, lastly, that's as far as I'm going to go on that one because we've been solving, and I don't want to overdo it. It's a lot, I know. So we're going to do the special cases, and then we're going to be done, and you'll have time to practice a little bit, and then you'll have time to practice some more tomorrow. No notes tomorrow. That's exciting. Okay? So 2 more problems. Let's look at the first one. These are special cases. Okay, I have to simplify both sides of the equal sign. Neither of them are simplified, so we've got to simplify them both, right? So I'm going to distribute. What's negative 2 times x? Negative 2x. Negative 2 times negative 5 is positive 10. Bring down a plus 10 equals. Is it all the way simplified? No. What can still be combined? 10, 10. What's 10 plus 10? Now is the left side all the way simplified? Okay, now let's focus on the right. Okay, my brain can't do both sides at once. I have to finish simplifying one side at a time. Okay, what am I going to do on this side? Distribute, and I get negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. And then I bring down that plus x. Is it in simplest form? No. What can be combined? Negative 3x and x. And what does that give me? Yep, negative 2x, and then bring down my minus 6. I combined those. That's how I got the negative 2. Oh, I did. Thank you. Okay, so knowing that, I need to move my smallest x. Well, they're the same size, so I'm just going to pick one. Plus 2x plus 2x. What happens on both sides? My variable cancels on both sides. They cancel. So I'm left with 20 equals negative 6. Is that true or false? False. So what do you think your solution is? Not false. No solution. Do y'all remember this big fancy 0? Okay, it just means no solution. Okay, so if your variable cancels and it does not make a true statement, it's a false statement, that means it's no solution. Okay? Everybody okay with that? So what do you think this one's going to be? Not quite all real numbers, same concept, but we call it infinitely many solutions. Pretty much just means everything's a solution. Could be a decimal, so on and so forth. Okay, so let's look at it. Is the left already simplified? So let's look at the right. 9 times x is 9x. 9 times negative 2 is negative 18. Bring down my plus 3x. How can that simplify further? 9x plus 3x gives me another 12x minus 18. What do you notice before we even keep going? They're exactly the same. So if you notice that, y'all, you can be done. Because when I move the variable, minus 12x, they both cancel, and I get negative 18 equals negative 18. True or false? True. So we call this IMS, which just stands for infinitely many solutions.